Hi all. Wait for everyone else to join, and then we'll start. Let's see. Hi Hitesh. Hi Rohit. Uh,
Hello.
let's give it a start. I believe. Okay. Give me 1 minute. I'll start sharing my screen. Okay. So until yesterday, we have looked into some basics. Let's continue from there. Just for the interest of time, I'm not repeating or I'm not doing any um, uh, revision of what we have done. Let me just quickly see. Give me 1 minute. There's something on the chat window. Let me just see. Good evening, Hitesh. I hope you can hear us, right? You can just quickly type on the chat window that you can hear us and you can also see our screen. Ah, great, great. Then let's start, friends. So, what to do is that let me take my pen. Yeah. Uh, yeah. So, let's start with the next set of actions. Now, things are going to become interesting. So, what we are going to do now, as a start, I'm going to look into the preparation stage. Okay, before I even move into the analysis side of things, right? Before I even move into the actual analysis side of things, I'll look into the preparation stage. Why I say that is because when I go into the application side of things, right, it is going to be something like this. As we were looking into yesterday, the first thing we do is that we visualize, right? We have to visualize the time series, right? After we have visualized the time series, what I'm going to do, I'm going to do EDA. Okay, you'll be surprised to know this is one such place where many of the problems will be solved, right? Or many of the questions can be answered. For example, trends, right? We can look into seasonality, right? We can look into cyclicity or any kind of cyclic patterns, or we can also look into errors and noises, right? So all of these things can come out of EDA without any statistical tests at all, right? Without any statistical tests also, right? There are tests, okay? There are statistical tests available to do this, by the way, right? Just like in statistics, if you remember, we looked into tests like Z test, T test, and so on. We have tests here like decupular test, for example. Okay? We have tests like decupular test. We are going to talk about the decupular test, hence don't worry right now, right? But EDA is going to be a very crucial part after we plot. So once we plot, we get some answers. Then we do EDA, we get some answers. Third, we do the actual statistical tests, okay, and inferences. Okay, so this is where we are going to do things like, let's say, auto regression, okay, moving average, okay, Holt's method, okay, Holt's winter method, right? Then it will be ARIMA, right? Then there can be SARIMA, right? So these are the techniques that we are going to use, okay, to basically decompose, okay, decompose the time series, right? And once the time series is decomposed, we will be able to know the structure, right? The format, the shape, or whatever characteristics we have. So we are going to learn about all the characteristics, right? The moment we learn about the characteristic, estimation is not going to be a problem because all of these you can consider just like the features, right? This will be the features of my time series, and hence using these features I can predict the outcome. So you can consider these as the x's or the xi's. And using the xi's, I'm going to estimate the yi, just like we used to do in case of regression. Only the methodology is going to change, right? We can even do regression, as I told you on the first session only, when it comes to time series analysis, but that's not the right way to do when it comes to univariate analysis, right? There is a reason behind it. We'll come to know when we do the implementations, we'll come to know, right? But this is going to be the general flow, right? The general flow, the flow of operations, you can say, is going to go like this. Now let's talk about the preparation quickly. So one question, if you remember in one of the sessions which was asked, is that what are we going to do when it comes to the pre-processing of the data? So this step is also the pre-processing, okay? Pre-processing of the data, right? What do we do, or why do we need pre-processing of the data? Is to improve the accuracy, right? Improve the accuracy, because basically what we are going to do is that, let's say if this is our plot, so I have x, have some xi, and this is which I have some yi. So these are my actual values, right? Xi and yi are my actual values, set of actual values. These are my actuals. And I would like to estimate something. For example, this is my time series as of now. And after I've done the estimation, let's say I've got an estimation for the next 2 weeks, which is something like this. So this becomes my yi hat, which is basically my estimation. If this is my estimation, what is my final goal? Right? If you look at my final goal, or if you look at my objective, it is as simple as yi minus yi hat. If I just take a, a, a function like this, I'm just going to reduce, and I'm also going to define these kind of metrics now. This is going to determine how good or how bad the estimations are. But my final goal, as you can clearly understand, is going to be something like this. I have to minimize. Okay, I have to minimize the difference between the actual value, which I don't know, by the way, the actual value which comes from the history, and the estimations, right? So this is my final goal, right? This is what I would like to do. This is exactly what I need to do, right? There is nothing else. If this is what I'm going to do, right, then we'll have to do some kind of pre-processing at the first place, so that I can improve the chances, I can improve the accuracy, or the estimation accuracy, right? So in that case, what shall I do? Two ground rules. I'm going to put down two ground rules. Okay, remember this by heart if you can, if you are going to work on the time series analysis, because time series analysis will be a quintessential part of any organization. In any organization, any work, will find time series analysis is a very, very crucial part. Two ground rules, right? Two ground rules. Ground rule number one, right? The data has to be ordered, right? We have already seen this. The data has to be ordered. That's why no gaps. Please don't tell me you have gaps in the data. If you have gaps in the data, you have serious bad luck now. If you have gaps in the data, there are other ways to handle this. For example, let's say you have day basis data, or you have daily data, convert it into weekly. Okay, fill the blanks, fill the gaps using some kind of a regression, or some kind of methodologies like these: AR, AMA, Halls Winter, and so on and so forth. Although Halls Winter is not going to be applicable in this case, more of AR and AMA will be applicable here, or even AR AMA. That is also one method by means of which maybe we want to reverse engineer and fill the gaps wherever there are gaps, right? But I don't want any gaps at all. This is going to be your mantra. The first mantra is going to be no gaps, because I expect an ordered kind of data. Ordered. Either it will be ascending or it will be descending. I don't know. Anything is good, right? But there shouldn't be any gap in the data. Don't tell me you have data for 1st March, and have data for 3rd March, and then again 4th March, and then again 10th March. This kind of gaps should not be there, right? The second rule, right? The second rule, which we need to maintain: do not, okay, under any circumstances, do not shift the series. Okay, do not shift the series. Estimate the values, that is better, but do not shift the series. For example, what about the value for 2? Let's say you have data, this data belongs to, let's say, okay, let's say this data belongs to March, okay, March 2021, and you are collecting this kind of data, let's say, from January 2020, right? From the previous history, right? From the previous history, Maybe you have lost this data. Let's say you lost this data. Now you have data from March 2021 until, let's say, now it is 2023. Just imagine that it is 2023, right? Just because you have missing data over here, don't shift places. Don't tell me that in the month of March 2021, I had bad sensors, for example, to capture temperature data, right? I had bad sensors to capture the temperature data. For example, let's say in this case, yi is the temperature value captured by my sensors, and xi is day or dates, each and every date. In March, I have many such instances where I have missing values. Okay, so I have done misses over here. So I'm not going to consider March. Let's start from April, right? Don't do that. It is not good. In this case, what is going to happen is your volume of data is going to get diminished, right? This kind of techniques are simply going to uh, diminish the data volume. Okay, you should not be doing that because I've already told you. I'm going to repeat it once more. Time series analysis needs good amount of data. Okay, it needs good amount of good data. Okay, you need good data and you need it in good amount. If you don't have that, you will have a lot of challenges doing the estimation. Right, we'll come to know once you look at the practicals. Right, we'll come to know what is going to be the usual problems. Okay? The usual problems that we are going to see. It is going to be very, very problematic. Really, very problematic. Right. Maybe I'll quickly show you today one example of time series analysis because next week you don't have any sessions, right? So I can quickly use, let's say, Tableau. Okay, this is one of the tools. I can quickly use Tableau and I can take a data of any airlines kind of a thing and I can try to do some kind of a time series analysis and I'll show you how to get the estimations. Okay, I know you guys don't know Tableau. That is okay. We can cover it in a later set of sessions. But just as an example, just as a quick example, we will take a kind of a data set related to airlines and we'll quickly see how it goes. Right. But these are the two ground rules: no gaps and no shifting. Right. And never do this. You are not supposed to do this. Right. If a few data points are missing, right? If I have problems with the data, what shall I do? Okay, it is good to say that, okay, don't do this, don't do that. But what shall I do? Let's say I have problems with missing data, right? If I have issues with missing data, right, what kind of approaches can I follow? One answer. Answer number one, let's say it can be, let's say, take average of nearest points. Okay, take the average of nearest points and fill the data or fill the gap. Okay, don't keep any gaps. If you see any gaps, this is where your SQL skills or Python skills or R skills are going to come handy, right? This is where your programming skills will come handy. Take the average of the nearby dates and you fill the gap. For example, again, our example, 1st March, we have data, 3rd March, we have data, right? If you have data for, let's say, 28th of February, and if you have data for 4th of March also, 5th of March also, let's say for 27th of February also, and only one day is missing, let's say here, you have 2nd of March which is missing, no problem, take an average. Okay, take an average of all these days, 1, 2, 3, 4, 5, 6. Right, to take an average of these 6 days, do a summation of the value, divide by 6, you got the average value, replace this gap with the mean, right? Replace this value with the median, right? These are the things which we have already done, right? When we looked into machine learning related areas. So you have to impute the data, don't leave any gaps. These are some of the ways in which you can impute the data. However, the only problem with these techniques is that, for example, this technique, right, where I was replacing with mean or I was replacing with median, this kind of technique only works if there is no seasonality. If there is no seasonality, for example, consider a data set something like this. 1st of August, I collected some data. 1st of July, I have some data. So basically, I have some monthly, okay, some data with a granularity of month. 1st of September, I have some data. 1st of October, I have some data. 1st of November, I have some data, which means this count belongs to the month of July. This count belongs to August, September, October, and November. For some reason, okay, for some reason, I have missed out on the August data. And even better, let's say this example, okay, belongs to the sales of units, okay, units of raincoats, right? If I take an average of July, September, October, and November and impute it into August, will that be the right thing to do? The answer is no. That will not be a good estimation. You know why? Because at least in Maharashtra, August is the most important month, right? Important month of monsoon, right? It is July from where it starts. August it goes into peak. By July end it goes into peak. August, full August, it will be at the peak. Then by September it is going to decrease. By October it is going to decrease, come down to November, right? So the graph is going to look something like this. This peak usually comes in the month of September. So this is a seasonality effect, right? This is a seasonality kind of a situation. In this case, if I'm going to replace with mean or with median, it's not going to be a good thing to do. So my estimation will go wrong, right? So there are techniques, but the techniques also has the limitations, right? So there are such kind of techniques that we will try to figure out from time to time, right? We may take help of other machine learning problems also, and we may try to fill the gaps. We will take help of other methodologies, for example, auto regression and moving average. These are very common methods by means of which we can also fill the gaps, right? And then for the actual estimations, we are going to use better or advanced models like ARIMA, right? I know you don't know these names, maybe, or maybe you have heard about them, maybe you have read about them on other sources. But please hold on to the questions. This will be clear once we go through them, right? Now, after this is done, after the data is ready, let's try to assume that my data is ready. Now the data is ready. Okay? The data is ready. Data is ready means what? It has no gaps, right? And I have not done shifting, right? I filled the gaps properly and I have not shifted the data. So I have good volume of data, right? And I have somewhat acceptable, I'll say, not excellent, but it's a good quality of data. So the data is there. Now, if I'm going to do any forecasts, right? Now, if I'm going to do any forecast, first of all, what do I need? I need the training data, right? I need the training data just like any regression problem or any machine learning problem. So this is my historical data, right? My trading data is my historical data, something which is happening for the last 5 years or 7 years or 10 years, right? It is not always the case that more data I put, more good the results is going to be. For example, I have a scenario where the trend is something like this. It is always an upward trend with some kind of irregularity here, which means even if I have 3 years of data, that should be enough. But if I have a situation where there is good amount of seasonality, right, then to capture the seasonality pattern, I need at least 4 to 5 years of data. That's the way to choose the volume of the data, right? That's the way to choose the volume, right? Yes, there are other methods, advanced methods by means of which we can even take data of 2 years and we can try to do things, but they'll not be as prudent as these kind of examples are. So depending on the kind of findings, I'll say, right, the findings of EDA and plots, the plots that we have done, the EDA that we have done, we have found something basis which we are going to have to come to a conclusion or an estimation of how much historical data we need. This will come from experience. Okay, there is no guideline. Nobody can really tell you, okay, take 5 years of data or take 7 years of data. This is the most valuable piece of advice I can give you. No, no industry expert can tell you that. It comes out of experience. If you ask this to a 20 years experience guy, he will tell you, right? He will be able to tell you that I used to work in retail where we used to use X years of data. In case of telecom, I used to use Y years of data, right? This kind of information, this kind of knowledge he has not got from books. He has got from actual practice, right? Practice means what? He has tried and he has failed, right? Then again he has tried, then again he has failed. A lot of to and fro has happened. Then he came to a conclusion, okay, for this domain, I need at least this much of data. In case I have only trend, no seasonality, I need this much of data. In case I have only seasonality as well as trend, I need this much of data. It comes out of experience only. There is no guidebook here, right? But how does he improve? How does one improve? I need to understand where it is failing, right? And this is where the metrics are going to come handy. I need to have some metrics, right? I need to have some metrics. And also I'll need to validate. So to do that in this case also, right, just like any other machine learning case, I'm going to have a training data and I'm going to have a testing data. So this is going to act as my validation set. Okay. The testing data is going to work as my validation set. I'm going to fit my model or do the estimations on the training data, and I'm going to validate it using the testing data. Right? It's going to be 70-30 kind of thing and so on. Right? Now, how do I measure the accuracy? Or what are the metrics? Right? Clearly, this is very, very similar to a regression problem. Right? Hence, the metrics are going to be similar to that also. The first metric which we use is the residual sum of squares. This is nothing but, as you already know from the regression session that we have had, the value of y at any given time t minus the value of y at any future time, yt hat. Yeah, you take a sum, do a square of the sums. This is the residual sum of squares. Yt is what? Something which has happened in the past. This is the past value or the training value. And this value is the estimated value, right? And the second thing is the mean sum of squared, mean sum of squared errors. It is nothing but 1 divided by t of RSS. T is what? How many time intervals I have taken. For example, in my data, I have collected weekly data of that example which I was taking yesterday of me being an ambulance driver. If you remember that example, what was the value of T? 540, right? If I'm not wrong, the value of T will be 540 because I have 540 rows of data or 540 time instances, right? I have 540 time instances. That is why I say my T is equal to 540. So I find out the difference, right? I find out the difference and use T. This can be smaller also. I can take it smaller also, right? It may depend how big or how small my testing data or my validation data is also. That is also another good technique, right? Then the third one is MAD, MAD, right? MAD means mean absolute deviation, mean absolute deviation, okay, which is nothing but 1 by t. I'm going to take a sum, and now what I'm going to do, y of t minus yt hat, and I'm not going to do a square. Instead, I'm going to take a absolute, right? I'm going to take an absolute value. So I'm taking a mean of the sum of absolute values. So mean absolute deviation, right? Fourth, these are the three things, right? These are the three things. Let me just repeat them once. The residual sum of squares. Second is mean sum of squares, which is 1 by t RSS. Three was MAD, right? Mean absolute deviation 1 by t summation of yt minus yt bar. And this one RSS was sum of yt minus yt bar or yt cap square. The fourth one, okay, these are the metrics that we are talking about, just to be clear. The fourth metric, a very common metric, is known as MAPE, right? This is mean uh, absolute percent error. How is this done? Carefully look at the formula, you will come to know how this is done. Sum, right? I'm going to take a sum, right, of something, and that something is going to be my actual value, y of t, minus the predicted values, right? I'll take this value, right? I'll take this value and take an absolute, and then I'm going to divide it by the actual value, right? I get a fraction, and now I multiplied this with 100, right? So the moment I do this, I get a percentage. So this is mean, uh, right? I'm taking mean. It is absolute. Here I'm doing the absolution, right? I'm taking a percentage, right? Because I'm doing a multiplication with 100 and I'm trying to calculate the error, right? So that's the name here. Mean absolute percentage error. Simple. There are many other matrices also. Lot others are there, but these are the most common, or you can also say these are the most easily applicable ones. For example, if you have a room full of people sitting in front of you where you have to present your findings, right? These kind of matrices will be very easy for you to explain, right? They are so easily mathematically formulated, or their mathematical formulation is really so easy that it is very easy for you to explain them, or it is very easy for you to present them. You yourself will be able to understand their significance really easily, right? Because the mathematics is not really very difficult. Any questions, friends, until this point in time? Any questions? Any doubts? I'm going to stop the sharing now for some time and quickly show you one example, and then we will go ahead. In the meanwhile, friends, I'll just be on mute for 2 minutes. Please let me know if you have any questions. Any questions, friends? Any questions at all? No, I see no questions from anyone. So let me quickly show you one example. Okay, let me quickly show you one example from, let's say, uh, I've opened Tableau from my side. I'll quickly share my screen also, friends. Give me 2 minutes. I'm just trying to find the data that I would like to show you. Give me 2 minutes, friends. Just 2 minutes. Mhm. Okay, I got some data. Good. Now let me share my screen. Okay. Thank you, Hitesh. Thank you so much. Yes, it is really interesting. The only thing is there are a few things that we have to take care of, which I'm going to explain you. So no problem. Now, I know that both of you may not really know anything related to Tableau, but I'll assume you don't know anything. But we are going to touch base on Tableau at a later time, right? As of now, what I'm simply trying to do is that I'm taking a data set, okay, which is this daily total female births, okay. This is, let's say, for the state of California in the US, right? This is a data set which is freely available, right? You can find these kind of data sets. Please note this if you want. There are websites like Quandl, there are websites like Kaggle, right? There are websites like data.gov.in or .us. Then there will be websites like UCI, Machine Learning Repository. Okay, so these are the places from where you will get data sets similar to this, which are already prepared for you. Okay, you have the date. This is day level granularity, by the way, and you have the number of births. Okay, number of female births. Okay, this is the data set. In real life, this will not be so easy, friends. Okay, let me quickly tell you what it is going to be in real life. In real life, you'll have 2 or 3 tables in some SQL database. or some NoSQL kind of a database, right? Or maybe it is there in big data platforms like Hadoop distributed file system, or it will be in cloud like AWS S3 or Google Cloud Storage and so on. You may not know these things right now because we have only covered the SQL part, which is okay. But over a period of time, obviously, we'll come in contact with the rest of the three friends also. So in there, let's say you have some kind of an infrastructure where you have tables T1, T2, and T3, and joining these three tables is by means of which you'll have to do a lot of cleaning of data, right? A lot of data wrangling, okay, or making it clean or making it tidy, right? There is a definition behind tidy data. If you want, please try to Google it. You will come to know what really is tidy data, right? It is not the literal sense, right? It's not the word. It is actually a very important process in the data analysis life cycle. You'll find a lot of blogs on Google if you would like to know, right? Once it is done, right? Once it is done, you will create, let's say, a final summary table, and the summary table is going to look like this. It's going to have two columns, C1 and C2, or a date and births, or X and Y, howsoever you want to represent, where you have a certain fixed format. You see the format here. It is DD hyphen MM hyphen YY. Even more interesting is going to be those days when, let's say, in your organization, if the organization where you are working, okay, you have, data quality teams, or you have master data management teams, they are going to set up rules, they are going to set up policies with respect to how this format of the data should be, what kind of granularity it should have, and so on. So taking care of all the data privacy policies like GDPR, and taking care of all the technical aspects, you'll have to finally arrive at this table, right? You'll have to finally arrive at this table, which you will have to create. In real life, nobody will give you the data. You will have to create it, right? But keeping that complexity aside, just to show you the example, you see here, you have date and you have birth, right? The first thing that we are going to do is plot. The second thing we need to do is EDA. The third thing that we have to do are tests. Now, because I'm using Tableau, okay, Tableau is, as of this version, the version of Tableau that I'm using is 2020.3, right? Tableau has two things, by the way, Tableau desktop and Tableau server. So let's not go into the details of them right now. We'll have different set of sessions maybe to go through Tableau, but as of now, just understand that Tableau here, okay, is just another BI or a visualization tool, okay? It's just going to do some analytics. It's just going to do some visual analytics with this tool. However, this tool has the capability for me to do good plotting, very, very good plots, and somewhat good amount of EDA, otherwise known as forecasts, okay, or trends. Okay, so I have two kinds of functionalities, forecast and trends, in Tableau, which helps me do good amount of EDA, right? It will not be able to tell me, it may not be able to break the data into trend, into seasonality, into cyclicity, into irregularities, and so on. Such kind of features may not be there in the current version. Maybe in the later version they'll add, right? But taking this data, we can quickly analyze. Okay, we can quickly analyze and see how it looks like, right? So let's do that. So what I'm going to do, give me 1 minute. I'll take this data, go to my worksheet where I'm going to create the things. I'm just going to take the date and the column shelf. I'm going to change this to day granularity. Right? Going to change this to day granularity. I'm going to take births. Okay. I'm just going to take this as a dimension. No, not going to be dimension. Sorry. Yeah. Right. Now this looks like a good chart. Right. This is the visual chart that I have. Okay. This is the visual chart which I have. This is a line chart, you can say. Right? At each and every point, I have the values, right? I have the values, right? So I have data from some year until some year, right? Or maybe I have data from 1st of January 1959 until what? 31st of December 1959, or maybe one more day. So maybe 1 year of data or 2 year of data I have. Okay. What are the properties do you see? The first property I see is the trend looks something like this, if I'm not wrong. So there might be some seasonality, right? But I cannot be sure because I have only 1 year of data. So year by year, if there is any seasonality, that I don't know. From this data, I don't know. So I will assume there is no seasonality. Okay? I'll assume as of now, I have no other option but to assume that there is no seasonality because I have no more than a year of data, right? I just have 1 year of data, which is 1959, right? Do I see a trend? That is the second question. The answer is yes, I do see a trend. If you look at this, there is clearly an upward trend, right? Clearly, there is an upward trend. I can call this line as my trend line, right? And there is an uptrend, right? So clearly, the data is going upward. So there is increase in the birth rates of females, right? Good observations already found. We may not have any seasonality, and we have higher birth trends, right? It means all the education that we are putting through in our schools, in our colleges, on the social media, and all the other platforms, it is really working towards the encouragement of people not getting any negative thoughts if they get any females as their child, right? So if a newborn child is a female, they should not really be worried, right? Some of the backward classes may have been, but over a period of time, it seems our overall education in the society, at least in this city, is increasing, uh, right? So it is going in the right direction, right? But why to take such kind of hypothetical answers by ourselves if we have the software? I'll go to the analytics tab, right? And I'll simply take a trend line. You see, there is a trend line over here. I'll take the trend line and I'll take a linear trend line. So I can clearly see there is a linear, right? There is a linear relationship here, and it has already given me. Okay, let me just find out what this value was. So, so the value of r squared is 0.075, right? And p value, okay, p value, as you can see on the screen, I hope you can see, p value is very, very less. P value is less than 0.0001, which means this is statistically significant, right? This is statistically significant. P value was less than 0.0001. So this trend is statistically significant, right? This trend is statistically significant. Now, why am I not able to do forecast? I'm not able to do forecast because Tableau needs an aggregate. So let me give it an aggregated measure and it should be able to do it. Don't worry right now, friends, if you don't understand these terminologies as to what is an aggregate and so on and so forth. Okay, we will come to know. Okay, we will come to know about this at a later stage. So don't worry. Right. So let me just remove this. Let me remove this. Let me just pull the birth over here. Right. So I now have the sum of births. Let me see if it is able to give me the forecast. So now I'm going to do a forecasting. Right. The moment I do a forecast, you see what it is saying. After the forecast option was enabled, what it is saying, let me change the color so that I can show you. Until this point in time, these are the actuals, right? So until this point in time, this is the actuals. This is where the actuals fall in, right? And here I have the prediction. You see, it is already labeled over here. This is where the estimate is, right? I'm going to analyze this estimate and see how different or how much is its spread, right? How much it is going to be spread out. So let's try to see that. And that is going to give us a good measure of how good or how bad the prediction is. Okay, see the forecast line is here, right? The forecasting estimate is something like this. So if I just click this and I can try to do something like this, I can do an edit and I can come over here and say what is 99% of, you have to be 99% sure, and I can increase this, right? I can increase this to the next 1 year or maybe to the next 1 month and so on. If I make the changes, right, you see the graph or the value over here, the value which is here on this side, this breadth is increasing, right? This breadth is increasing. Please remember this breadth. Okay, this breadth is really important. This is the range in which the values can fall. It is the range of the estimate. bigger the range, right? If the range is really big, right, less optimal the output is. I ideally want a forecast line which is something like this, and the range should be something like this. Just like you can try to compare this with the soft margin classifier which we have seen in place of SVMs. The margins around the forecast line. Okay, this is the forecast line, let's say. The margins, these are the margins. Okay, the margins should be as small as possible. Higher the margin, bad the estimates. Lower the margin, good the estimates. Now, in this case, I selected an estimation. I asked Tableau to do an estimation of the next 1 month. You see the breadth here. You see the margins have increased, right? What happens? Let me just clear the drawings. What happens if I come over here and I select automatic and select 10 days? Is the margin increasing or is the margin, let's say, decreasing? It is almost the same. Almost the same, right? Let me change this to 1 day, right? Even in this case, the margin is big, right? So it with 99% prediction accuracy, it is not really going that good. What about, let's say, 95? You see the breadth has reduced. If I go to 90, the breadth has reduced a little bit. So why not go with 3 weeks, right? Now the breadth has reduced because I have changed my prediction interval to 90%. If I increase it to 95%, the width increases. If I increase it to 99%, the width increases. So what does this mean? More I am trying to be accurate, the more I am going towards accuracy, right? My margins, okay, are getting flatter. Okay, this is going to be the case because more I'm trying hard, really. I'm really trying hard to be as accurate as possible, let's say in my math exam. The more I try, the more hours of study I put in, I'll have less hours of sleep. And hence, obviously, I'm going to have repercussions with respect to my health. Right? So that is exactly what is happening here. It is exactly what is happening over here. The more you look for accuracy, this kind of margins will increase. How do you take care of that? Increase the data. Simple. There is no other way. You have to increase the data, or you have to increase the quality of the data, or you have to use different or advanced methods. Right? There are 3 ways. Try the one which you can do. Maybe you have data, then increase the data. Maybe you have further options to improve quality of the data. Maybe there were missing data, right? So try to fill in the values. Or you try advanced methods, which we are going to learn in the deep learning area of things, right? I hope, friends, this gave you a quick idea about what a time series is finally going to look like, right? It's going to look something like this. We are not going to use Tableau, obviously, because we don't know Tableau, right? So we are not going to use this. So let me close this. Let me stop the sharing and let me close that, right? I'm not going to use that tool because we have not really read about it, right? So we are not going to use it. We are going to use Python to do it. But this is how a final time series model is going to look like. Any questions, friends, until this point in time? Any questions?
No questions from my side.
Okay, thank you, Rohi. Any questions from you, Hitesh? As of now, great, no problem. Thank you, friends. Thank you. Then let's do one thing. Let's make it a close for today, right? As I informed on the group, I will be on leave for the next 1 week, right? I'll be taking a break after a long time. So I'll be back by 1 week. So most probably we'll start the next set of sessions by 6th, by the 5th of April, right? Please ensure you are going through the materials. Please go through other, let's say, resources on the internet also. If you find any doubts, if you have any queries, please do let me know, friends, and I'll try my best to resolve them. Yeah.
Sure, Bhaumik.
Okay, friends.
Yeah. Happy holidays.
Thank you, Rohit. Thank you, Hitesh. See you.
Good night.